Fourier series in pi form. That is, we have to take f of x is equal to 1 by 2 product pi minus x in the interval 0 comma 2 pi, and let me see how to expand this function as a Fourier series in the given interval. Before let me move on to the given problem, let me have a short look over the formulas which we are going to use in the problem to calculate the Fourier coefficients A0, An and Bn. So this is one of the very important formula you have to remember. So Bernoulli's formula. Integral uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v both are functions of x, and u dash, u double dash and u triple dash, it's an infinite series. It goes infinitely and it has to stop whenever the value of u double dash or u triple dash becomes 0. Okay, up to that we have to calculate. So u dash is nothing but du by dx, and u double dash is equal to d square u by dx square, and u triple dash is d cube u by dx cube, etc. Or in other words, we have to say this as u dash, u double dash and u triple dash, etc. These are successive derivatives of u. These are all successive derivatives of u. And v1, v2, v3, etc. These are all successive integrals of v. That is, v1 is equal to integral v dx. And integral v dx is nothing but v1. v2 is nothing but integral v1 dx. If you integrate v1, then that is v2. And v3 is integral v2 dx, etc. So v1, v2, v3 are successive integrals, whereas u dash, u double dash, u triple dash, etc. are successive derivatives of u and v. This is one of the very important formula you have to remember. So this is what we have to use to calculate the Fourier coefficients An and Bn. For calculating A and Bn, we make use of this formula. And the next one of the important thing you have to remember is, while substituting the limits, you should know the values of cosine and sine terms in terms of n pi and 2n pi. Cos n pi is minus 1 whole power n, whereas cos 2n pi is plus 1. Because n pi is minus 1 whole power n means 2n pi means minus 1 whole power 2n, isn't it? So shall I write this as minus 1 whole square power n? Minus 1 whole square is plus 1 itself. 1 power anything, 1 itself. That's why you have cos 2n pi is plus 1. So cos n pi minus 1 whole power n, whereas cos 2n pi is plus 1. Here sin n pi is 0 and sin 2n pi is equal to 0 if n is an integer. So in pi form here we have to take n is in terms of integer. So sin 2n pi here becomes 0 itself. So besides this, these are the formulas you have to study in your school days. This is a basic differentiation and integration formula, that is integral x power n dx is equal to x power n plus 1 divided by n plus 1, whereas d by dx of x power n, that is the derivative of x power n, is equal to nx power n minus 1. So listen here, I have to just recall one more thing. While you differentiating x, that is d by dx of x is nothing but, so here the power is 1. Okay, that is understood. So if it is x, that we understood that having the power 1. So based on the formula nx power n minus 1, isn't it? So 1 x power 1 minus 1, that is 1 minus 1 is 0. Am I right? So you have x power 0, anything power 0 is 1. So while differentiating x, you get 1. Okay. Likewise, while differentiating a constant, suppose if you take a constant c, whenever if you differentiate a constant, you get 0. Okay, so differentiating a constant gives you 0 and differentiating x you get only 1. Whereas in case of integration, suppose if you are going to integrate x, okay, if you are going to integrate x with respect to x, what happens? Based on the formula, what is x power n dx? X power n plus 1 divided by n plus 1. So that is understood that x is having power 1. So x power 1 plus 1 divided by 1 plus 1. That is x square divided by 2. Am I right? So while you integrating x, you get x square divided by 2. And also integrating a constant with respect to x means you have to take c outside of the integration. So c integral dx, you get only cx alone. So integral dx is x. So when you integrating a constant, you get cx, right? Whereas differentiating a constant becomes 0. Okay. So this is the main important difference you have to know about differentiation and integration. Now next one, integral cos nx dx is equal to sin nx divided by n, and integral sin nx dx is equal to minus cos nx divided by n. This is a formula. These two formulas you have to remember. This is what we are going to use in calculating the Fourier coefficients. Now, for this short revision about the important formulas, let me now enter into the problem. Before that, I just give you a short hint about Fourier series in pi form, how we are going to express in terms of pi form and how we calculate the Fourier coefficients. Okay, so Fourier series in pi form can be represented, that is f of x is equal to a naught by 2 plus sigma n varies from 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity b n sin nx. Here a naught, a n and b n, these are all constant. So by make use of this Euler's formula, you calculate the Fourier coefficients a naught, a n and b n, and substituting these values in f of x, that gives you the Fourier expansion of the given function. Okay. So for that, we make use of the formula a naught is equal to 1 by pi. Here the interval is from here in pi form. Here we have to discuss the functions in the interval 0, 2 pi. So the integral takes the lower limit and upper limit value 0 to 2 pi. And a n is equal to 1 by pi, integral 0 to 2 pi f of x cos nx dx. And b n is equal to 1 by pi, integral 0 to 2 pi f of x sin nx dx. This is the formula you should remember. So if it is in pi form, so the given function is in the interval 0, 2 pi. So this is the formulas you have to remember to calculate the Fourier coefficients. Okay. Now let me now enter into the problem. Expand the function f of x is equal to 1 by 2 pi minus x as a Fourier series in 0 less than x less than 2 pi. That is the length of the interval given as 0, 2 pi. Now we have to expand this function as a Fourier series. For that, first you have to write down the given function. Given f of x is equal to 1 by 2 pi minus x. So now, you know, first let me write the Fourier series expansion of the given function f of x as a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity b n sin nx. Here we use the formula a naught is equal to 1 by pi integral 0 to 2 pi f of x dx, and a n is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So first we calculate the value of a naught, and then we go and calculate the value of a n and calculate the value of b n. After calculating these three values and substitute in the function f of x, you take this as equation number 1. If you substitute in equation 1, the problem will be over. So now let me first calculate A naught. So A naught is equal to 1 by pi integral 0 to 2 pi f of x dx, that is equal to 1 by pi. You just replace f of x by the given function. Given function is 1 by 2 pi minus x, isn't it? F of x is what a given function. So 1 by 2 pi minus x dx. So this is equal to 1 by, here 2 is a constant, so you take it outside of the integral. So 1 by 2 pi integral 0 to 2 pi minus x dx. What you are going to do next is, you have to split the integral into 2, or otherwise if you know very well in integration, you have to do it directly. So if you are a beginner in this concept, I will explain how to integrate this. Okay. Now, while integrating, first we have to divide this into 2 parts. That is, put a big parenthesis, 0 to 2 pi, integral 0 to 2 pi. First we have to write pi dx. Minus, because here we have minus symbol. So minus integral 0 to 2 pi, then x dx. As I told you already, so that is equal to 1 by 2 pi. Here pi is a constant. Here integration is with respect to x. Here we have pi. So pi is a constant. What we are going to do next? So you have to take it outside of the integral. If you take outside of the integral, what you get? Integral 0 to 2 pi, only dx alone. Minus, write this as it is. Next step we have to integrate. Okay. Now, that is equal to 1 by 2 pi. While integrating, what you get? Pi. While integrating dx, what you get? You get only x. Minus, while integrating x, what you get? So, what is the formula for integral x power n dx? That is equal to x power n plus 1 divided by n plus 1. So, instead of n, here we have 1. So, if you substitute n is equal to 1, because here we have x, that is addressed to that, it has a power 1. Am I right? So, substitute n is equal to 1, what happens? X power 1 plus 1 divided by 1 plus 1, that is x square divided by 2. So, integral x dx. Am I right? Integral x dx is equal to x square divided by 2. So, x square divided by 2 with the limit 0 to 2 pi. So what is our next step is, let us substitute the limit. First we have to substitute upper limit and then we have to substitute the lower limit. So substitute the limit for x term. So if you substitute the limit for x, what happened? So that is equal to 1 by 2 pi. Put a big parenthesis and sub parenthesis. This is for upper limit minus lower limit. Okay. Now I have to put a big parenthesis that covers these two parentheses. This sub parenthesis, this is for your upper limit minus. Always we substitute upper limit value minus the lower limit value. So this again sub parenthesis for your lower limit value. Now we have to replace first x by 2 pi. So pi of 2 pi minus 2 pi the whole square divided by 2. Okay, upper limit over. Minus, let's come to the lower limit. If you replace this x by 0, what happens? Pi product 0 is 0. Minus lower limit here itself, here you have 0. So 0 squared by 2, 0 itself. So there is no lower limit. So which implies your A naught is equal to 1 by 2 pi. So within parentheses you have 2 pi square minus 4 pi square divided by 2. So what happened here? 2 pi square minus 2 pi square. Here 2 is a common factor. If you cancel this, what you get? 2 pi square minus 2 pi square, which means 1 by 2 pi of 0. So 2 pi square minus 2 pi square becomes 0. So here a naught is 0. So our first Fourier coefficient a naught value for the given function is 0. Now, let me now calculate the value of a next. Now, read the formula once again. A is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. First, we have to replace f of x by the given function. So, 1 by pi integral 0 to 2 pi. Here f of x is 1 by 2 pi minus x. Am I right? Product cos nx dx. So 2 is a constant, so take it outside of the integral. So 1 by 2 pi. So in the next step you take it outside of the integral. So 1 by 2 pi integral 0 to 2 pi pi minus x product cos nx dx. Look at here. In the integration, you are having product of two functions. That is in terms of x. Pi minus x is a function of x and cosine function is also a function of x. So you can't directly integrate this. For this, we make use of the formula, Bernoulli's formula. That is what we have discussed earlier, isn't it? So you know integral uv dx. Whenever there is a product of functions, so we make use of this Bernoulli formula and integrate that. Okay. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. So it's an infinite series. So whenever the derivative value becomes 0, we have to stop up to this. Now here, this is in our problem. We have to take the first function as u and the second function as v. So here we have to take u is equal to pi minus x and v is equal to cos nx. First let me differentiate the function u. If you differentiate, what you get? U dash. U dash means you have to differentiate this. As I told you already, if you differentiate pi, that is pi is a constant. If you differentiate a constant, what you get? 0. Whatever that may be pi, it may be c or a, any constant. Okay. So if you are differentiating a constant, you get 0. Minus x. If you are differentiating x, so what is the formula for differentiating? So d by dx of x power n is equal to n x power n minus 1. So while differentiating a constant, you get 0. That is d by dx of a constant is 0 always. Right? That's why our first term while differentiating becomes 0. Minus x. If you are differentiating x, what you get here? N is equal to 1. Am I right? If you substitute n is equal to 1, what you get? 1 x power 1 minus 1. That is 1 product x power 0. That is anything power 0 is, that is this value becomes 1. So 1 product 1, that is 1. That is understood. Am I right? So d by dx of x is 1. So if you are differentiating x, you get 1. So here u dash is equal to minus 1. What is here u double dash? Yes, minus 1 is a constant. Minus 1 is a constant. If you are differentiating a constant, your value is 0. So u double dash becomes 0. So in the Bernoulli formula, so we have to calculate up to this itself. Am I right? So u double dash becomes 0. So we don't need any terms after this. So integral uv dx for this problem, integral uv dx is equal to uv1 minus u dash v2. Up to this we have to evaluate. Next, we calculate the values of V1, V2 next. So V is cos nx, your V1 is nothing but integral cos nx dx. Am I right? So when you integrating cos nx, what you get? That is equal to sin nx divided by n. While integrating cos nx, that is equal to sin nx divided by n. Next, your V2 is, that is again you are going to integrate V1. Your V1 is sin nx by n. Here 1 by n is a constant, so you take it outside of the integral. So 1 by n integral sin nx dx. While you integrating sin nx, what you get? Minus cos nx divided by n. While you integrating this sin nx minus cos nx divided by n, already we have one n in the denominator, that is we have one more n in the denominator, so n product n becomes n square. So your V2 is minus cos nx divided by n square. So now we calculate integral u v dx is equal to u v1 minus u dash v2 and substitute the limits. Next, now, so now let me calculate value of an. So an is equal to 1 by 2 pi u. What is your u? Here your u is pi minus x. Your u is pi minus x. So u pi minus x. V1. Your V1 is, what is your V1? Your V1 is sin nx divided by n. So your V1 is sin nx by n. So sin nx divided by n. So u V1 minus u dash V2. So what is your u dash? So u dash value is minus 1. U dash value is minus 1. So u dash V2. Sorry. What is your V2? Your V2 is minus cos nx divided by n square. Your V2 is minus cos nx divided by n square. So minus cos nx divided by n square with the limit from 0 to 2 pi. Now before we substituting the limits, let me simplify the symbols. Here we have three symbols. First we simplify this, then only we can't make any mistakes by omitting any of the plus minus symbols. Okay, so that is equal to, which make our calculation much easier if you are doing so. Okay, 1 by 2 pi. So there is no plus minus term here, so write it here as it is. So pi minus x sin x divided by n minus, because here we have 3 minus terms. So 3 minus, that is minus itself, minus cos nx divided by n square with the limit from 0 to 2 pi. Look at this. Now it will be easy for us to substitute the limits and simplification too. So mark the x terms here. So here these are the places we have to replace the x value first by 2 pi and then by 0. Now as usual, as I told you already, 1 by 2 pi, put a big bracket, okay? And then within that you have 2 sub brackets. This is for upper limit minus, and this is for your lower limit, okay? Upper limit minus lower limit. First let me substitute the upper limit value. That is 2 pi is the upper limit value. By substituting the upper limit, look at here. This is your first term. Am I right? Here you have sine term. As you know already, sine, if you replace this x by 2 pi, what you get? Sine 2 and pi. So what is the value of sine 2 and pi? Sin 2n pi is 0. Am I right? So sin 2n pi is 0. So no need to substitute here. 0 into anything 0. So entire term becomes 0. Minus. So the first term becomes 0. Minus. Coming to the second term, cos, if you replace this x by 2 pi, what you get? Cos 2n pi. What is the value of cos 2n pi? Cos 2n pi value is plus 1. So here you have 1 divided by n square. So in the upper limit you have 0 minus 1 by n square minus lower limit. Coming to the lower limit value here x takes is 0. So if you substitute 0, what you get? First look at the sine term. So if you replace this x by 0, what you get? Sine 0. The value of sine 0 is 0. So this entire term becomes, sine 0 becomes 0 means the entire term becomes 0. So here the first term as usual becomes 0 because sine 0 becomes 0 means it is in product. So the entire term becomes 0. Minus cos, if you replace this x by 0, you have cos 0. Cosine 0 is, cos 0 value is 1. That is 1 divided by n square. Okay. You have no need to replace the value x by 2 pi and replace the x by 0 and write the terms. That's not necessary. You know already the values of sin 2n pi, cos 2n pi, sin 0 and cos 0. So whenever there is a limit, so immediately directly you have to substitute the values and write it here. Okay. That is equal to 1 by 2 pi. So in the upper limit, this is your upper limit minus lower limit, isn't it? So you have minus 1 by n square. Here you have minus. So these two minus becomes plus. That's why I told you. So you have to put a big parenthesis, upper limit minus within minus lower limit. These two are separated by two separate parentheses. Some of the students make mistake at this point. So they leave this minus and make it as positive means here you have minus term. So the value becomes changed. Okay. So plus 1 by n square. So here minus and minus becomes plus. So what happens? These two terms become cancelled. So here itself, so 1 by 2 pi of 0. So product of any value with 0 is 0 itself. So your a in value here we have obtained as 0. Next we calculate Bn. To calculate the value of Bn, we make use of the formula 1 by pi integral 0 to 2 pi f of x sin nx dx. Look at here. First we have to replace as usual f of x by the given function, that is equal to 1 by pi integral 0 to 2 pi. Your f of x is the given function, that is 1 by 2 of pi minus x product sin nx dx. Here 2 is a constant, so take it outside of the integral in the next term. So in the next equation, that is 1 by 2 pi. So as in the next step, what you are going to do? So in the next step, you have to take the 2 outside of the integral. So 1 by 2 pi integral 0 to 2 pi pi minus x sin nx dx. Look at here, this is also product of two functions. Okay, so if it is a product of two functions, we can't directly evaluate the integral. So for that we make use of the Bernoulli formula, that is we make use of the Bernoulli formula, integral ub dx is equal to uv1 minus u dash v2. So we have to stop up to this because your u dash becomes minus 1 plus u double dash v3 minus etc. Now here we have to take u as pi minus x and b as sin n x. So if you take u is equal to pi minus x and b is equal to sin n x, let me see what are the derivatives and integrals we are going to get. Okay, now u dash is equal to differentiating, there is no change. Okay, and pi minus is differentiate, that is what we have to do in case of a. The same value can be obtained because we have same function u, because in calculating an2 we have to take pi minus x as u. While calculating bn, we have to take pi minus x as u. Only the difference is, while calculating an, here we have take, instead of sin n x, we have to take cosine n x. Here we have to take sin n x. That is the only difference. Okay. So here I have to write the values directly without much explanation. Okay. So this is what we have discussed already. So while you differentiating this function, so pi, that is a constant, becomes 0. While you differentiating x, you get only 1. So u dash is equal to minus 1 and u double dash becomes 0 because this is a constant. By differentiating a constant, you get 0. Okay. Since u double dash becomes 0 means we have to stop up to this. So we don't need any terms after this in the formula. Okay. So now we calculate v1 and v2. Okay. Now for calculating v1 is equal to integral sin nx dx. While integrating sin nx, what you get? So as I told you already, so integrating sin nx gives you minus cos nx divided by n. And v2 is equal to integral. Here, look at here, we are going to integrate this once again. While integrating this, minus and 1 by n is a constant, so you take it outside. So minus 1 by n cos nx dx. While integrating this cos nx, what you get? That is sin nx divided by n. Already you have minus and n in the denominator, so you have to add this. Minus, already you have n. So now you are having one more n, so n product n is n square. So your v2 is minus sin nx by n square. Okay. Now let me now substitute the Bernoulli's formula here and substituting the limits to get the value of bn. So our bn is equal to 1 by 2 pi of uv1. What is your u? Pi minus x. So u is pi minus x and v1 is minus cos nx dx. So formula is uv1 minus u dash v2. Okay. So u is pi minus x and v is minus cos nx divided by n. So minus cos nx divided by n uv1 over minus u dash. U dash value is minus 1, isn't it? Your u dash value is minus 1. U dash v2. U dash or v2 is minus sin nx divided by n square. That is minus sin nx divided by n square with the limit from 0 to 2 pi. Now let's simplify the symbols to simplify our calculations. So here we have only 1 minus. So in the next step, 1 by 2 pi, you take the minus to the beginning. Okay. So minus pi minus x cos nx divided by n. Here we have 3 minus. So 3 minus means minus itself. So pi minus x cos nx by n minus sin nx divided by n square with the limit from 0 to 2 pi. Here you mark the x terms. positions, we have to first substitute the upper limit value 2 pi and lower limit value 0. Okay, at these positions you have to first substitute the upper limit value and lower limit value. So 1 by 2 pi. So as usual, put a big parenthesis which covers the entire term. Within that you have two sub parentheses, upper limit minus lower limit. Okay. So let me now first substitute the upper limit. So look at the cosine term first. So cos n, here if you replace x by 2 pi, cos 2n pi. You know the value of cos 2n pi, that is plus 1. Am I right? So 1 divided by n. Here you have minus pi minus, here you replace x by 2 pi. So minus pi minus 2 pi of 1 by n minus. If you replace this x by 2 pi, what happens? You get sine 2n pi. You know the value of sine 2n pi is 0. So 0 by n squared is the entire, this term becomes 0. Minus lower limit value. Coming to the lower limit value, first we have to substitute 0 for x. So minus pi minus, you just replace this x by 0. And you know already cos 0 is 1. If you replace this x by 0, what you get? 0. Cosine 0 is 1. So 1 divided by n minus sine 0 value, you know already. Sine 0 value is 0. If you replace this x by 0, what happens? Sine 0. So sine 0 is 0. So the entire term becomes 0. Now simplifying this, what you get? That is what we are going to see. So 1 by 2 pi of, so minus pi minus 2 pi is minus pi. Am I right? Of 1 by n. Minus 0, you just leave this term. So in the upper limit we have this term. Minus, coming to the lower limit. So here we have minus pi of 1 by n. Okay, here the parenthesis is very important. So if you leave any of the parentheses, definitely the sign of the term becomes changed. So the value become wrong. Okay, so this is equal to 1 by 2 pi. These two minus becomes plus. So here you have pi divided by n. Okay. Here itself you have minus into minus. So minus into minus becomes plus, and also pi of 1 by n is nothing but pi by n. So adding these two, you have 1 by 2 pi of 2 pi by n. So cancelling these two pi terms, what you get? Which is equal to 1 by n. So the value of Bn is equal to 1 by n. Okay. Now let me substitute the values of a0, an and bn in f of x. So this is what are f of x. So this is equal to your a0 value we have arrived as a0 is equal to 0 and an is also is equal to 0 and bn, that is what just now we have calculated, that is 1 by n. Let's now substitute all these values. So a0 becomes 0 means the first term becomes 0, isn't it? Plus an becomes 0 means what happens? The second term also becomes 0. Plus sigma n is equal to 1 to infinity. Here bn is 1 by n sin nx. So your f of x is equal to sigma n is equal to 1 to infinity 1 by n sin nx. So for the given function, the f of x is equal to 1 by 2 of pi minus x. This is what the given function. Am I right? F of x is equal to 1 by 2 of pi minus x. So for the given function, this is the Fourier expansion. Okay. I think we got a clear idea about how to calculate the Fourier coefficients. If the function is given in terms of pi form, Thanks for watching. See you all again in my next video.